equation is f2, which is a function of x and y, and that is equal to 0. So this could be anything, right? I mean, you could have something like xy plus x squared is equal to 0, or you could have under root plus x cubed. Just an example. I don't know whether the solution will exist on this for this equation or not, but I just want to tell you that this would be something like f1 xy, and this could be something like f2 xy, and this is a hypothetical. Okay, so you'll be given these two, and you would have to find out approximate solution to this problem, which means you have to find out the values of x and y that will simultaneously satisfy. Okay. So basically, you're trying to look for some, let's say you're trying to look for some root and yi. After I number of iterations, you get this is the solution, approximate solution. So you have to come up with some value of x, come up with some value of y, such that both these equations are less than some epsilons. Satisfied with that epsilon, you would be like, okay, solution on here, something like that. So how do we proceed with this? Since there are two variables and introduction method moves around with one assumption, so that means that you require one assumption for assumption of y to begin with. Let's say let us say that x0 and y0 set of assumptions. And let h and k be the small corrections. X and y. So if x0 is the initial assumption, then x0 x assumption. So here also, if x0 is the first assumption in x, then x0 plus h is the first assumption, first approximation. If y0 is the initial approximation, then y is the next approximation. So we know then you can write in general, you can write that let x be x0 plus h and let y be y. So assuming that the above two equations, the next step is that x0 plus h, y0 plus k is equal to plus x0 plus h, y0 plus k is equal to. You can write it like this. Now, as this function, it's a f1 is a function of two variables, and f2 is a function of two variables. So now, if we need to expand them in Taylor series, it will be Taylor series for a function of two variables, right? So, of course, h and k are very small, so we don't really need to go beyond 1, h square, h cube, k square, k cube, all those powers can be neglected. So to the first approximation, the first approximation. The first approximation, expand the series as follows. Can be written as f1 x naught y naught plus h times del f1 over del x evaluated at x naught plus k del f del y evaluated at x. Similarly, if it was one variable, it would have been f1 x naught and h del f1 del x plus h square by 2 factorial del square f plus del x square. So यहाँ पे भी अब यहाँ पे दो वेरिएबल हैं तो एक h वाला डिफरेंशिएशन एक k वाला डिफरेंशिएशन, फिर नेक्स्ट टर्म में h square by 2 factorial del square f1 by del x square at x naught y naught plus k square by 2 factorial del f1 del y del 2 f1 del y square at x naught y naught plus h cube by 3 factorial, and it will just continue like that. We don't really need to go there because up to first approximation is okay, because we are assuming that h is much less than 1 and k is much. We stop here. Similarly, f2 x naught plus h y naught plus k can be f2 x naught y naught plus h del f2 over del x x0 y0 plus k del f2 del y x0. So these are up to first approximations, and I'm letting it move. Okay. So now I know that the first one will be equated to 0 and second one will be equated to 0. So then now I get this equation. So I get this equation, which is h del f1 over del x at x naught y naught plus q f1 del y at x naught y naught is equal to 0. So I can write minus f x0. I've skipped one step. What I meant was that I would have just equated this to 0, and then I would have equated this to 0, and then I would have taken f1 x naught y naught to the other side. So I would get this equation, and then the second equation would be h del f2 over del x at x naught y naught plus a del f2 del y x naught y naught, and this will have been minus f2 x0. So I get these two equations, first equation and second equation. Now the idea is to find the values of h and k, like in the one-dimensional method. The idea was to find h, right? Now you see that these are two equations. Now we know what is x naught, we know what is y naught, because these are initial assumptions. We know what is the form of f1x, we know what is the form of f2x. When I say form, I mean what is exactly the function. Like the form of f1x in this case is xy plus x2 is under root y plus x naught, right? So I know, substitute the values of x naught and y naught in f1 and f2, then these two are right. It could be positive, it could be negative. it would be some number. So these are some numbers. Okay. When I evaluate del f partially differentiating f1 with respect to x, here I am partially differentiating to y, right? So once I do that, I differentiate it with respect to x as a x naught and y naught, I will get a number. Only in f1 del f1 over del y, when I substitute x naught and y naught, I will get a number. So this is an h some number plus k multiplied by some number is equal to some number. So this is like a linear equation in h and k, right? When you come down to the second here also, you will have some number plus k number is equal to some other number. This is also a linear equation h and k. So now the problem is simple in the sense that now you have a system, two linear equations in h and k, and you really need to find out the value. You know the methods of doing that. Last 9th and 10th, this is much like something like this. So now you have a capital X plus B is equal to C, and you have B capital X plus E capital Y F, right? So you have a system like this where this X is your H and this Y is your K, and this A, C, and F are some constants, right? So you eliminate, or whatever method you apply, you can solve it. So, but we are going to look into it from like a linear kind of a matrices. So if you look at that, then I can write this solution as something like this. So this is going to be, I think you know this because you must have done it in class 12. So this would be F1 x naught y naught minus F2 x naught y naught. This would be del F1 del y, del F2 del y. They are evaluated at x naught y. I should probably write it. So I can write it as del F1 over del y. Evaluated at x naught y naught and del F2 over del y. Evaluated at x naught y naught. This is your h, okay, divided by the determinant of the initial matrix. I'll tell you what D is. So let me now write K. K is going to be del F over del X. Del F del X evaluated at x naught y naught F1 x naught y naught minus F2. This, and then you have this, right? Now D is the determinant. D is what? D is del x x0 by 0 x0 by 0 del f2 and del x x0 by 0 f2 and del y x0 by 0 and del 0. Okay? So this is the determinant. So you know how to solve this determinant. It will be del f1 over del x multiplied by del f2 over del y minus del f1 over del y into del f2 over del x. Right? So this is how you can find h and k. And once you have h and k, then you have x1 and y1, and then you just keep on iterating it that way till you reach some level where you can say, okay, I have reached. So this is how you find h and k, and then your next iteration, your x1 is going to be x0 plus h, and your y1 is going to be y0 plus h. And once you find x1 and y1, then you repeat this entire thing, and then you repeat all of these things at x1 and y1, right? X0 and y0 will now be replaced by x1 and y1. Then you will find x2 and y2. Then everything will be replaced by x2 and y2, and then you continue. You can keep on doing that for till you reach whatever reasonable you know, convergence you're looking for in terms of 3 decimal places or sorry, 4 decimal places. So this is in general for two systems of two variables. Now let's say that if you had a system of 3 equations, how will you approach that system of 3 equations? So how do you think? So there will be one function which will be f1, which will be a function of fyz equal to 0. Then there will be some f2, which will be a function of fyz is equal to 0. The f3, which will be a function of fyz is equal to 0. Then how do you proceed? So you will take an initial assumption of x0, y0, z0. Then you will take h, k, and l. These are the initial corrections. So you will get a point which will be h naught plus x. You will get a point which will be y naught plus k. You will get a point which will be z naught plus l. Right. So then I just write for first function. So f1 would become x naught plus h, y naught plus k, z naught plus l equals 0. And you will get some other equations also like this. So let me just write it fi, where I is 1, 2, and 3. So this is how you can just write it. So if you have to expand this in first orders of h, k, and l, then what would this be? So if I write fi as x naught plus h, y naught plus k, z naught plus k, z naught plus l, this is k, and this is. So what would this be? This would be fi x naught, y naught, z naught plus h del fi over del x evaluated at x naught, y naught, z naught plus k del fi over del y evaluated at x naught, y naught, z naught plus l del fi over del z evaluated at x naught, y naught, z naught. Right? Similarly, you all others. So this is like for I equal to 1, 2, and 3 because there are 3 functions. So now you will have, so if you, when you solve this, you will get a system of 3 variables, linear equations. You will get a system like h capital X plus k capital Y plus lz equal to, let's say, a, right? Where your x is going to be del fi over del x, your y is going to be del f1 over del y, and z will be del f1 over del z. Then you will get h x1 plus ky1 plus lz1 equals p. Where your capital X1 will be del f2 by del x, y1 will be del f2 by del y, z1 will be del f2 by del z. And then you will get del capital X2 plus ky2 z2 is equal to c, right? And this a will be minus f1 x naught y naught z naught, b will be minus f2 x naught, and c will be minus f3 x naught y naught z naught. a system of three equations which you need to solve. So you can do it in this determinant and you'll get the values of h, k, and l, and then the next iteration will be h naught plus h, naught plus h, k, and you can complete. So no matter how many variable equations you have, all that you have to do is formulate this matrix, solve for h, k, and l using matrix algebra, and then the next iteration will come, and then you just proceed on that. So this is basically the method of doing solving systems of linear equations using approximation. We'll look into one example also, just to give you a sense of what we have done. I'm just going to solve it for one iteration, and then you can proceed further with the second iteration in the same manner. I give you the answer also, I have it, so that if you solve it by hand, solve maybe for one or two iterations, because that should give you an idea of how to do it in case it comes in the exam. But once you write a code, then things will be much easier. So let's say that I give you an equation which is x square minus y square 7 is equal to 0. I give x xy plus y is equal to 0. And I say that let's begin the initial iteration at 3.5 as the initial iteration. So let's proceed with this one. So f1, I'm not going to write x comma y because that's understood. So f1 is x square minus y square 7. f2 is x minus xy plus 9. So this is given to us. So so the first thing that we need to do is find those partial derivatives. So del f1 over del x, that is going to be 2x. Okay. f1 over del y is equal to minus 1. Del over del x 1 minus 5. Del f2 over del y is going to be 9. So I find out what this code. I start my first iteration. So first iteration, x naught y naught is 3.5 comma 4. Now I find out all f1, f2 and all the partial derivatives at these points. So f1 is 3.5 square minus 4.5 square plus 7, and this value comes out to be equal to minus 1. I know this, I have a written solution, so you don't need to solve, just look at it. Then second is f2. f2 is going to be 3.5 minus 3.5 multiplied by 4.5 plus 9, and that is minus 3.5. Then over del x, this is 7. You just multiplying 2 with 3.5. Del f1 over del y is y, which is going to be minus 9. Del f2 over del x is 1 minus y, which is 1 minus 4.5. So this is minus 3.5. And del f2 del y is minus x, which is minus 3. Okay. So these values, I find out d. This is the determinant. So determinant was, if you look at it, so del f1 x into del f2 y. Okay. So this time, so this is del f1 into del x into del f2 into del y minus del f1 del y into del f2 into del x, right? Yeah, so this value comes out to be 7 into minus 3.5 minus 3.5 into minus 2. Yeah, right. So what is this value? This I don't have. So let me just, can anybody tell me what would be this value?
So 7.
Huh?
7.
7.
Or -7. Sorry.
Wait, so this is 3.5 into 9, 31.5 minus 31.5, and then 3.5 into 7, this is 24. So this is minus 24.5. ये होगा ना, कुछ गड़बड़ कर रहे हैं, ये भी माइनस साइन है, ये भी माइनस साइन है, तो ये तो प्लस हो गया, तो इधर माइनस आया, इधर माइनस ही है. So this is going to be minus 56.
56 minus 56.
Minus 56, right? So this is your D. Okay. So now, now what is your H and what is your K? So if you look at H, if you look at this formula, the one that I've written over here, this formula for H, so so that will be determinant of 1 and 3.25, because वो दोनों का माइनस लगेगा ना, और यहाँ पे you have minus 9 and minus 3.5 divided by minus 56. So if you solve this, it will be 1 into minus 3.5 minus 9 into 3.25 divided by minus 56. जब करोगे तो आंसर आएगा 0.459. एक बार जरा चेक करो यही आ रहा है कि नहीं, एक बार चेक करो.
Yes, sir, it's correct.
It's correct. Your H, and then based on the formula that I had written for K, you will get 7 minus 2.5 1 2.25 divided by minus 56. If you do this, you will get minus 0.48. So x1, which is 0 plus h, will come out to be 0.402, and your y1 is going to be y naught plus k, it will come out to be 4.0. So now you get x y1 as 2.042, 4.0312. So this is now your next approximation. So now you will start with x1 and y1. So if now you move to next approximation. So when will you stop? And x1 y1 is some pair, and your x2 y2 is also some pair which has a similar number of some decimal place. You just stop there. So let me just write something. Now you start. Now you start with assumption as 3.040 to 4.0, and then you proceed entire thing you do further, you will get to x2, which will be 3.03, and you will get to which will be 4.001. Okay, so this will be your x2, y2. Then if you go to iteration 3, start with 3.03 and 4.01, and then end up with x3 as 3.0000 and y3 as 3.0000, and you will see that after this you will see if you take the four types. Sorry, this is um, if you look at it, if you do a four type, will not be any change in this. So your answer will be seeking for this problem. And if we kind of know problem, so square which is 9 and 4 square which is 16, you subtract it, you get minus 7 plus 7 is equal to 0. Proper solution here also, if you have 3 into 4 plus 9, you get 0. So you know the solution that was there was 3 and 4 only for this. So you come to this after 3 iterations. So this is how you solve Newton-Raphson method for two variables. Now you can see how complicated it is if you do it by. So let's say that I give you a problem like this. I'll be very merciless if I ask you to evaluate the entire thing. So generally, these kind of problems are given to you solution, or if at all, I have to give one problem, like a simple enough problem that will converge after maybe these types of something, one dimension. The problem will be that you'll have to form equation maybe, or you'll have to equation so that I know that you have to form it as a basic methodology. So this is basically two dimension. Okay, and then a little bit about that will come if we have a Newton-Raphson method or what are shortcomings when we get. I think we'll see enough for today because so and it's an online class. We'll do some Excel examples for third and the methods, the four methods that we've done. And write a code for MATLAB code for all these. And maybe we can to write once you have written the codes for all the four basic one dimension. Then the assignment for this unit could be that you write a code yourself for a 2-dimension or a 3-dimension problem. So I think we are more or less over by the end of this week. Too much now. Just have to write some codes. To solve the problems that you pose yourself, so that it is just a revision. So I see you tomorrow also, but in the online mode. But I don't mind that happens in the. So if there is any problem, if there is any question pertaining to what we've done today, you can ask. Otherwise, we can just end the class. Not many people are joining now. So there are only 58. There was a time when we had 50 people joining. I think people are forgetting the fact that there is an attendance criteria also this time for every course. So please convey this to your friends. And I'll be very strictly enforcing it as per the dean's instruction. especially when enough days have passed. Which is very-
Hello, sir.
All right then. Good day.
Hello, sir.
Yeah. Bolo.
I have a doubt.
Yeah, John. Tell me.
Sir, till
Yeah.
when do we iterate this process? Like,
So you iterate. So like okay. So if you look at it, if you look at x2 and you look at x3, I mean we've got a complete solution 3 and 4 in this case, but you can iterate it up to that point where the ith iteration and I minus 1th iteration have some decimal digits which are similar. Like for example, if you look at it 3.0003 and this is 3.0000. So now these two x2 and x3 are similar up to 3 decimals. Do you agree,
yes, sir. Yes, sir.
Johan?
Yes,
So
sir.
this is 3.0003 and this is 3.0000. So up to this point, let me just do it now that you're asking. So if you, I have kind of removed the system. Just a second. Yeah. So if you look at it, this and this is similar. So if I say find out the root up to 3 decimal places, so
So
you
you have
stop
not
here.
shared the screen.
Oh, okay. Just a second. Just a second. Yeah. So if you look at x2, then it will be 3.003 and x3 is 3.0000. So if I would have said find the solution correct up to 3 decimal places, then if you look at x2, then up to 3 decimal it is 3.000 and x3 is 3.000. So there is similarity up to 3 decimals. So we'll stop here, right? This is how you stop. If you look at y2, then y2 is 4.000 up to 3 decimals and y3 is 4.000 up to 3 decimals. So if I say find out the solutions to a system of equations up to 3 decimal places, then you stop at the third iteration. I hope you understand, right?
So, sir, we have to
So
check whether the digits after the decimal is equal, like similar.
yeah, so yeah, similar, yeah, equal. You
Yes.
can say equal also. So it could have been 3.272, and if you would have got 3.275 something, then you would have continued further till you get those 3 digits after decimal same. You know, the ith iteration and I minus 1th iteration. So that is how you proceed. That is always how you proceed in this problem, whether it is to get into or not. Okay, is that clear?
Yes, sir. It's clear.
Okay, thank you. Anything else, or we can just stop?
Thank you,
Okay.
sir.
Bye-bye. Good.
Thank you, sir.